Hey, what's up everyone? It's Mr. Lang, and in this video I'm going to show you how to solve quadratics by completing the square. So let's get started. Alright, first question here. It says we want to solve x squared plus 2x minus 5 equals 0. And we can tell that this is a quadratic because we got the leading x squared. So the way we've been doing this is to solve by factoring. And since it's already equal to 0, we're good there. So usually what we do here, there's no GCF. So we're going to solve by using the windows. So I'll make my window. Put my x squared here. Put my minus 5 here. And I'm going to put my x and my x here. And what I want you to do is pause the video and see if you can solve this. And when you're ready to go, unpause it and we'll go over it. Alright, so you gave it a shot. How'd it go? Probably not very well because you probably figured this out. It is not factorable. It doesn't matter what you try. You can try a negative 5 here and a positive 1 here, and you're going to get 1x and negative 5x. That adds up to negative 4x. That doesn't work. The only other thing I can try is to make this a positive 5x and a negative 1x. That would make this negative 1x and positive 5. Still doesn't work. So this is not factorable. So what do? This is the only way I taught you how to do these. Well, that's what we're doing in this video. I'm going to show you another way. So you can't solve by factoring if it's not factorable. So what we're going to do is I'm going to show you how to solve by completing the square. And this is something actually we're already familiar with. We would put our quadratics in vertex form by completing the square. Well, now I'm going to show you how to use that completing the square technique to solve. Alright, so let's do the same problem again, except by completing the square. So remember what we would do with the vertex form to put it in vertex form. I've got it equal to 0 already, so that's good. And what I'm going to do is put the x squared plus 2x, and then I do the plus a blank. Alright, then I've got the minus 5 from up top, and since I added some mystery number here, I've got to subtract that mystery number as well in order to balance it out. And instead of being equal to y like before, now we have equal to 0. Alright, because we're trying to find those zeros. And it's been a little bit, but to find what goes in the blank, we take the b term here, the 2, we divide it by 2, which gives us 1, and then 1 squared is equal to 1. So 1 goes in here and in here. Then what we do is we take this perfect square trinomial and we put it into its factored form. Well, the number we squared to get 1 was 1, so this is plus 1 squared. And then minus 5 minus 1 gives us minus 6. And this all equals 0. So it's kind of like we put it in vertex form and then set it to 0, but not much different than what we did before. But now this is where it gets a little different. What I want to do is solve for x. So the first thing I'm going to do is get this minus 6 on the other side by adding 6. So that leaves me with x plus 1 squared equals 6. And solving equations is all about doing the opposite. If you've got a minus 6, you add 6. If you've got like 2x, you would divide by 2. It's all about those opposite or inverse functions. So think about, well, what is the opposite of squaring a number? Well, it's taking the square root. So what we're going to do to undo the squared is to take the square root of both sides. Now here's the one kind of weird thing that you got to remember to do, is that when you take the square root of the number over here, it becomes a plus or minus. It could be positive square root of 6 or negative square root of 6. All right. So this undid the square, so we're left with just x plus 1 equals plus or minus 6. I'm sorry, plus or minus square root of 6. And then to get the x alone, it's one last step. Subtract 1 from both sides. And I'm going to put the negative 1 first. So it'll look like kind of what we were doing in previous video. It's negative 1 plus or minus square root of 6. And that's our answer. So this really means two things. Remember, the plus or minus is just a shortcut. X could be equal to negative 1 plus square root of 6 or negative 1 minus square root of 6. That's what that means. And listen, we could put this in the calculator and get a decimal to see what we would get, but normally we like to leave it in this form because it's exact. We're not rounding anything. Alright, so there was a lot there, a lot of complicated stuff, but we know how to do most of it. But let's do 2 more examples and I think you'll start to get the hang of it. Alright, number 2 says p squared minus 6p is equal to 20. Well, the first thing we need to do is get it equal to 0, so I'm going to subtract 20 from both sides. So we're going to get p squared minus 6p minus 20 equals to 0. Again, I'm going to put the p squared minus 6p plus a blank minus 20 minus the blank is equal to 0. Half of negative 6 is negative 3. Negative 3 squared gives me positive 9. So 9 is going to go in both my blanks. Now I'm going to put this perfect square in factored form. And half of negative 6 is negative 3. So it's p minus 3 squared. Minus 20 minus 9 is minus 29. And this all equals 0. So this is step 1. Step 2 is now solving this. So I want to get the p minus 3 squared alone, so I'm going to add 29 to both sides. So we've got p minus 3 squared is equal to 29. To undo the squared, I'm going to take the square root. And again, same thing, I got to make this a plus or minus. This leaves me with p minus 3, no square root, no square, equals plus or minus square root of 29. And now to get p alone, I add 3 to both sides, which gives me p is equal to, and again I'm going to put the 3 first, 3 plus or minus square root of 29. And that's my answer. And one thing you want to look for is to see if this square root needs to be reduced any, or simplified. Not reduced, simplified. But there's no perfect square that goes into 29, so this is done. Alright, last one. We've got x squared minus 10x minus 11 equals 0. And it already equals 0, so that's a good thing, one less step to do. So let's get right to the completing the square part. It's going to be x squared minus 10x plus a blank minus 11 minus the blank. And that all equals 0. Half of negative 10 is negative 5. Negative 5 squared is positive 25. going to put this in its factored form. Half of negative 10 is negative 5. So it's x minus 5 quantity squared. Minus 11 minus 25 is minus 36. And that all equals 0. So that's step 1. Step 2 is to solve. I'm going to add 36 to both sides. This gives me x minus 5 squared equals 36. Now I take the square root of both sides, and I got to remember to make this a plus or minus. Alright, so this gives me x minus 5 equals plus or minus the square root of 36, but check this out. The square root of 36 is 6. It's a perfect square. So this comes out to be plus or minus just a 6 with no square root. We'll talk about this in a second. So now I'm going to add 5 to both sides. And I get x is equal to 5 plus or minus 6. So what this means is that I've got two answers. Just like before, x would be 5 plus 6, which would be 11, or x would be equal to 5 minus 6, which would be negative 1. And this didn't come out to be radicals or decimals or anything. These are integers. What that means is that up here, right at the beginning, this was factorable. We could have done the window method. Check this out. We could have done negative 11 and positive 1 here. So we would have got x minus 11, x plus 1, and when we set them equal to 0 and solve, we would have got an 11 and negative 1. So, I mean, doing it by factoring, I think, is way easier. If you can factor, do it that way. But we did this by completing the square. Completing the square always works. All right, but it is a little bit more work. So if you can factor, do it that way. But if it's not factorable, then complete the square. So just kind of in summary, we now know two ways to solve quadratics, by factoring and by completing the square. Listen, if you can factor it, solve by factoring. It's usually faster, and plus you guys are really good at it. Completing the square, though, will always work, even on factorable quadratics, and we saw that. But it's just like having another tool in our tool belt. Having two ways to solve allows us to choose the best method. So listen, if that went a little quick for you, you can always rewind and watch it again. Thanks for listening.